Welcome to the deep dive. Today we're diving into something really quite extraordinary that gripped Europe just recently, the June-July 2025 heat wave.
Yeah.
And look, this wasn't just a hot spell, was it? It was, well, extreme. It shattered historical records, caused huge disruption, and honestly, it felt like a real watershed moment.
Absolutely. And our mission here, as always, is to really unpack a whole stack of sources. We've got the latest scientific analyses, European Commission reports, real-world impact stories from the ground.
Right.
We want to give you the clearest possible picture of not just what happened, but, why it matters and what it might be signaling for our future.
And what immediately jumps out, I think, from looking through all this material is how unequivocally this extreme event was shaped by climate change. So we'll explore the devastating human toll, the economic costs, which were huge, and what it really means for Europe's urgent need for, well, both adaptation and, crucially, mitigation efforts. It's a proper news deep dive into a crisis unfolding right now.
Yeah, definitely. Let's start maybe by looking at the sheer scale of this thing. The June-July 2025 heat wave. I mean, it's been described as a definitive and brutal manifestation of accelerating climate change.
Brutal, yeah.
And what's particularly striking, I think, is that it wasn't just one single event. It was actually two distinct heat waves back to back.
Right, like a double whammy.
Exactly. The first hit around June 17th to 22nd, and then almost immediately, an even more intense one kicked off from June 29th to July 2nd. And that compounding stress, well, that was a critical factor in just how lethal it became.
You can almost feel that stress just looking at the numbers, can't you? June 2025, it became the warmest June on record for Western Europe.
Yeah.
The monthly average was nearly 3 degrees Celsius above the recent average. That just edged out the infamous 2003 heat wave.
Which was devastating in its own right.
Absolutely. And the daily temperature for Western Europe peaked at nearly 25 Celsius, something you normally expect much, much later in the summer.
And those impacts were felt so acutely across the continent. I mean, Portugal hit a mainland record, over 46 degrees. Spain saw its national June record broken, 46 degrees again. France had widespread areas over 40, leading to those highest-level danger-to-life alerts.
Wow.
But it wasn't just the raw thermometer reading, was it? The feels-like temperatures, which factor in humidity.
Yeah, that humid heat is the worst.
It really is. It exceeded 38 Celsius in huge regions, and there was one area northeast of Lisbon where it apparently felt like 48 degrees Celsius.
48. Good grief.
Yeah, and this humid heat, combined with what they call tropical nights, where the temperature just doesn't drop significantly, it severely hampers the body's ability to cool down. It creates this constant, relentless health risk.
That paints a really, really stark picture of the scale. But, okay, how did Europe get so hot so fast? What were the atmospheric conditions that set up this deadly double blow?
Right. So the primary atmospheric driver was something scientists call a heat dome.
Okay, I've heard that term.
Yeah, it's basically a strong, persistent, high-pressure system that just parks itself over an area, in this case, Western Europe. It acts like a lid,
Trapping the heat in.
Exactly. It traps hot, dry air that had been pulled up from North Africa. And then that air sinks, compresses, and just heats up more and more day after day.
So we've got this strong heat dome acting like a lid. But was there anything else going on? Something maybe amplifying it? Something perhaps less obvious that really cranked up the intensity?
Yeah, there was. And this is fascinating, actually. It's the crucial role of what's called the land-sea feedback loop.
Okay.
So while the heat dome was baking the land, it was also warming up the Western Mediterranean Sea to exceptional levels. We saw record sea surface temperatures for June. Some areas were showing anomalies like over 5 degrees Celsius above average.
5 degrees.
Wow, which is huge for the ocean. And this abnormally warm sea then fed back into the atmosphere. It helped reinforce the heat dome's stability, made it stronger, and crucially, it stopped coastal areas from cooling down properly at night.
Ah, right. So no relief even by the coast.
Precisely. And that's what worsened those already extreme feels-like temperatures and just intensified the heat stress on millions of people.
So, okay, connecting the dots here. What does this all mean regarding climate change? You mentioned the sources of the analysis. They quickly concluded this heat wave's intensity was, quote, unequivocally amplified by human-induced climate change.
Unequivocally, yeah. That's the word they used. Attribution science, which is this pretty cutting-edge field comparing real events to a hypothetical world without human warming, delivered some really dark findings very quickly.
Okay.
Studies from places like the London School of Hygiene and Tropical Medicine,
Right.
Imperial College London, working with world weather attribution, they showed this heat wave would have been between 2 and 4 degrees Celsius cooler without the roughly 1.3 degrees of global warming we've already caused since pre-industrial times.
2 to 4 degrees cooler.
Yeah. And London specifically got nearly a 4 degrees Celsius boost just from climate change.
That 2 to 4 degree boost. I mean, it sounds significant, but maybe for the average person, it doesn't immediately convey the full gravity. How do those seemingly few extra degrees translate into, disproportionately larger damage and deaths? What does it mean for systems to cross these critical thresholds?
That's such a crucial point because it's not linear, right?
Right.
It's like imagine a bucket that's already almost full to the brim. Those few extra degrees are like adding just a tiny bit more water, but it's enough to make the whole thing overflow catastrophically.
Okay, good analogy.
So for our health, for infrastructure, it means pushing past these critical points. The body's ability to cool itself might suddenly fail beyond a certain temperature, or power grids buckle when demand spikes past capacity. So that seemingly small temperature increase caused disproportionately larger damage and deaths because it tipped systems from just being stressed into outright failure.
That's a profound shift, isn't it? And how we have to think about risk. It really backs up what the IPCC, the Intergovernmental Panel on Climate Change, has been saying.
Absolutely.
They project that the frequency and intensity of these hot extremes will just keep increasing across Europe, which, let's face it, is warming faster than the global average anyway.
Indeed. And what was once a really rare anomaly is rapidly becoming, well, the new normal.
Yeah.
Take London again. A heat wave of this magnitude is now expected roughly once every 6 years, without human influence. Maybe once every 60 years at most.
Wow, a tenfold increase.
A tenfold increase in frequency. And this also highlights a really profound direct link. These scientific analyses didn't just connect climate change to the weather event itself.
Right.
They connected it directly to the lethal consequences. Researchers stated quite unequivocally that the additional deaths were a direct result of the extra heat added by climate change, which is caused by burning fossil fuels. It creates this clear and powerful causal chain, as they put it, a chain of accountability, really.
And those deaths. That brings us to the really tragic human toll. Heat's often called a silent killer, isn't it? Because it worsens underlying conditions, maybe doesn't get listed as the main cause on death certificates, and the official stats often lag behind.
Exactly. That's why these rapid analyses done right after the 2025 event were so incredibly important. One study, just looking at 12 European cities, estimated that around 2,300 people died from heat-related causes in just a 10-day period.
2,300 in just 12 cities.
Yeah. But here's the really crucial part. Around 1,500 of those deaths, that 65%, were a direct consequence of the extra heat added by climate change.
Wow.
So, in a world without global warming, the death toll in those cities might have been around 800. Human-caused climate change effectively tripled the number of fatalities in that sample. Tripled. And the full toll across all of Europe, well, it's likely in the tens of thousands.
2,300 people in just 12 cities, 1,500 directly linked to climate change. That's a number that really, really stops you in your tracks. It's easy to talk about degrees Celsius and economic impacts, but these are real lives, real families just devastated. It really underscores why we're doing this deep dive, doesn't it?
It absolutely does. And this heat wave, like most disasters, didn't affect everyone equally. The data clearly showed that between 80 and 88% of the excess deaths were among people over 65.
So hitting the elderly hardest.
Overwhelmingly, highlighting the extreme risk to Europe's aging population. But there's also a disproportionate burden on low-income households, people working outdoors. Tragically, a street sweeper died in Barcelona from heat stroke.
Oh, terrible.
And people living in poorly insulated housing. And that's made worse by the urban heat island effect in cities where it's always hotter, and also by energy poverty, people unable to afford cooling.
And the strain on just basic systems was undeniable, right? Emergency rooms, schools.
Completely. Emergency department visits doubled in France during the peak. Physician consultations tripled. Daily life was just severely disrupted. France closed over 1,300 schools. Italy banned outdoor work in the hottest hours in 13 regions. Even the Eiffel Tower had to close its top levels. That's a significant societal cost beyond the tragic deaths.
So, beyond the human toll, this heat wave really acted like a massive stress test for Europe's entire economy, didn't it? triggering these cascading failures across critical sectors.
It really did. And nowhere was that clearer than in the energy sector.
Right. It sounds like it was a perfect storm, soaring demand meeting crippled supply. What exactly happened there?
Well, you nailed it. Soaring air conditioning use caused daily power demand to shoot up by up to 14% continent-wide at the peak.
14%, that's huge.
It's massive for a grid. But at the same time, the heat itself was crippling the generation side. High river water temperatures and low flow levels meant thermal power plants couldn't cool themselves effectively.
Especially nuclear plants.
Especially France's nuclear fleet, yeah, which relies heavily on river water. At least 7 gigawatts of capacity were forced offline. Some plants, like Gulfec, had to shut down completely for periods.
And this mismatch? Demand up, supply down? It must have sent prices skyrocketing.
Exploded them. Average daily electricity prices jumped by 2 to 3 times across the board. I mean, imagine your electricity bill suddenly tripling overnight.
Unbelievable.
In some areas like Poland, those peak evening prices surged over 470 euros per megawatt hour. That's just unsustainable for many businesses and certainly for households.
So what does this tell us about maybe the energy transition? Was renewables a help or a hindrance here?
That's a really interesting point. It showed both the promise and peril, you could say. On the one hand, record solar generation during the day was absolutely critical. It acted as a stabilizing force, likely preventing wider blackouts.
Okay, so solar helped.
Definitely. But on the other hand, the crisis really hit hardest in the evenings when the sun went down, and demand remained high. And that brutally exposed a critical gap in grid-scale energy storage.
Ah, batteries.
Exactly. The heat wave showed, very clearly, that without enough large-scale battery storage, the grid remains incredibly vulnerable when solar power drops off. But demand stays high.
So moving from power to, well, plates, agriculture was also hit catastrophically, based on the reports. How did the heat affect food production?
Yeah, catastrophically is the right word. The combination of that extreme heat and the pre-existing drought conditions, it led to really significant crop yield reductions, particularly in southern Europe.
What kinds of crops?
Things like corn, grapevines, olive trees, they're highly vulnerable once temperatures get up past 40 degrees Celsius. That kind of heat can cause pollen sterility in corn, or make grapes shrivel on the vine, directly hitting yields and quality.
And livestock, too, I imagine. Heat stress must be terrible for animals.
Absolutely. The dairy industry, in particular, was thrown into what one report called a catastrophic tailspin.
Wow.
Milk production forecasts for the EU were slashed significantly. You know, high-producing dairy cows can start suffering heat stress at just 22 degrees Celsius.
Really? That low?
Yeah. So these extreme temperatures just hammered milk production and quality. And this was made worse by poor quality forage for feed due to the drought, new EU tariffs on some agricultural imports adding cost pressures, and even disease outbreaks linked to the stressed conditions.
So the ripple effects just kept spreading beyond energy and farming.
Oh, indeed. Tourism saw dips in popular spots like Athens, threatening livelihoods. Labor productivity plummeted. Some studies show workers can lose up to 50% of their work capacity when temperatures get above 34 degrees.
50%.
Yeah. And while we don't have the final bill for 2025 yet, we know from historical data that extreme weather cost Europe something like 738 billion euros between 1980 and 2023.
Staggering figure.
It is. And this heat wave will undoubtedly add a very significant chunk to that total.
So beyond the human and economic devastation, the environmental damage was also severe, potentially long-lasting. It paints this picture of a scarred landscape.
Yeah, definitely. Remember, this heat wave didn't happen in isolation. It was superimposed on and made much worse by severe pre-existing drought across large parts of Central, Northern, and Eastern Europe. Slovenia, for example, had its hottest and driest June on record.
And that creates a feedback loop, right?
Yeah.
Dry soil gets hotter.
Exactly. It's a vicious feedback loop. Dry soil can't provide evaporative cooling, which normally helps moderate temperatures, so the ground heats up more, which heats the air above it even more. Europe's average relative humidity actually hit a new record low in June because of this widespread dryness.
And all that dry vegetation. It must have created a tinderbox across the continent. Wildfires seemed inevitable.
They were an inevitable and devastating consequence. We saw huge destructive wildfires break out across the Mediterranean, France, Spain, Greece, Portugal, Turkey. Extremely. Tragically, 2 farmers died in Catalonia, Spain, caught in a fast-moving fire. And the smoke plumes from these massive fires also aggravated the public health crisis, adding respiratory problems on top of the heat stress for millions.
And the environmental damage went beyond fires, didn't it? affecting ecosystems on land and sea.
Yes. Terrestrial ecosystems, especially forests already stressed by drought, became less vital, more susceptible to pests like bark beetles, which can cause widespread dieback later on.
Right.
And in the sea, that exceptional Mediterranean marine heat wave we talked about created hypoxic conditions, basically, dangerously low oxygen levels. This threatens marine life, reduces fish growth, and can cause mass die-offs of species like corals or shellfish.
And this wasn't just contained to Europe, was it? There were global connections.
No, absolutely not. The same large-scale atmospheric patterns that caused the European heat wave also led to record-breaking heat in places like Iceland and Greenland. And relatedly, Arctic sea ice extent reached its second lowest level for June in the satellite record. It really shows how interconnected our global climate system is.
Okay, so this brings us to Europe's response, or maybe the lack thereof in some ways. The catastrophic outcomes of 2025 really seem to highlight what the reports call a profound adaptation gap. What does that mean in practical terms?
It means that basically the existing strategies Europe has to cope with heat are just not sufficient. They're often described as a dangerous patchwork of uneven and often underfunded initiatives.
A patchwork?
Yeah. A WHO survey from 2022 revealed that only 21 out of 57 countries in the WHO Europe region and just 14 within the EU itself actually had a national heat health action plan in place.
That's surprisingly low.
It is. And funding is a massive barrier. The EU put about $113 million into heat adaptation research via its Horizon Europe program, but honestly, that's a tiny fraction of the investment needed across the continent. So you get these big disparities in how prepared different countries or even cities are.
So despite these gaps, are there blueprints for resilience? What is actually working on the ground? Are there places getting it right, preparing for these hotter futures?
Yes, absolutely. Despite the challenges, there are definitely models of good practice out there. The EU does have an overarching adaptation strategy that provides a framework. And some countries, like Portugal, Austria, England, have established fairly comprehensive heat health action plans.
And cities often lead the way, don't they?
They really do. Cities are often hubs of innovation here. You see things like Paris's Paris Under 50 Degrees plan, which focuses heavily on planting trees and creating cool spaces. Lisbon has its Life Lungs project doing similar urban greening.
And it's not just about trees, presumably. I've seen reports about infrastructure changes, social support.
Exactly right. Rotterdam in the Netherlands is doing really interesting work on heat-proofing buildings through innovative design and materials. Helsinki is expanding its district cooling network, basically providing efficient, centralized air conditioning to whole areas.
Like district heating, but for cooling.
Precisely. Malaga in Spain has set up air-conditioned climate refuges, where vulnerable residents can go to escape the heat during the day. And the German city of Worms even has a telephone, a heat hotline, where volunteers check in on vulnerable residents.
That's a great idea.
It is. And then you have legislative tools like the EU's Energy Performance of Buildings Directive, pushing for better insulation and renovation through national plans. These are crucial for climate-proofing housing stock long-term.
So, looking ahead, what's the unflinching forecast from the IPCC? Is 2025 just a taste of what's coming, or was this hopefully some kind of peak?
Unfortunately, the IPCC projects with high confidence, as they say, that the 2025 heat is not an endpoint, but a milestone.
A milestone. Towards worse.
Towards an even hotter future, yes. The frequency and intensity of hot extremes are projected to continue increasing across all of Europe. And remember, Europe's land areas have already warmed by about 2.2 degrees Celsius compared to pre-industrial times in the last decade alone, faster than the global average.
And the specific projections are pretty terrifying, aren't they?
Yeah.
It sounds like adaptation, while important, might simply not be enough on its own.
They are deeply worrying. The European Environment Agency warns that if the planet warms by 3 degrees Celsius globally, which is currently plausible under existing policies,
Right.
then heat-related deaths in Europe could increase 30-fold compared to the recent past. 30-fold.
30, wow.
And by 2050, maybe half of the entire European population could be exposed to high or very high heat stress during summer. And that risk isn't just confined to Southern Europe anymore. It's projected to expand significantly into Western, Central, and Eastern Europe, too.
So adaptation has limits.
It absolutely has limits. While adaptation strategies like the city plans, the building codes are vital and will save lives, they simply cannot fully protect society against a significantly warmer world. I mean, no amount of tree planting or cool pavements can make a 50 degrees Celsius city truly livable or safe for everyone. So the 2025 heat wave really delivers a final urgent message, I think. Adaptation without mitigation is not a strategy for resilience. It is a strategy for managing an orderly collapse.
Wow. Managing an orderly collapse. That's quite a phrase.
Yeah.
This deep dive into Europe's summer of 2025, it's revealed a truly systemic shock, hasn't it? Unequivocally amplified by climate change.
Definitely.
It exposed just how fragile our systems are: health, energy, food, the environment. And it showed that nonlinear nature of climate risk, where just a few extra degrees didn't just add deaths, they tripled them and pushed infrastructure past breaking point.
It's such a clear illustration of the lethal reality of social inequality, too, who gets hit hardest, and, frankly, the inadequacy of Europe's current adaptation efforts. This event really has to be treated as a final warning, doesn't it? A catalyst for real, transformative, continent-wide action.
The science seems incredibly clear. Every single fraction of a degree of warming that we can prevent through aggressive mitigation, cutting emissions, has this outsized benefit in saving lives and protecting our economies.
Absolutely.
This deep dive into Europe's summer of 2025 is a stark warning indeed. So the question for you listening is, what will you do with this knowledge, knowing that, well, the hottest year we'll have for the rest of our lives might just be behind us, unless we act, and act now?